can see there are host A tries to ping to host B. Let's take an example here. So what I'll do is I'll try to simulate one example here. Now you can simulate as if we have a switch 1 and then we have a switch 2 and then switch 3. So typically they might be connecting on the same network or the same branch office. And as we discussed, there will be a traditional L3 links. It will not be using the traditional links. In fact, they'll be using the layer 3 links with the help of OSPF. They will learn the information. So we assume that as if we have a host A, and this host A is trying to communicate with the host B, which is on a different switch, and assuming they are in the same VLAN. Same VLAN, here we call it as a VNI, or basically the same VLAN or same network. Okay. Now, the first thing is the host A will try to ping to the host B. So what I'll do is I'll just say ping, let's say 1.1.1.2 will generate a ping request. That's what the first thing. And as we know, the entire communication process within the layer 2 network is not done based on the IP address. It will be a broadcast. It will be based on the MAC address. So which means there will be an ARP protocol, just like a traditional method. There will be an ARP which is going to request for the IP address. But again, the thing is, this ARP message is not broadcasted. Unlike in the traditional method, the ARP messages will be broadcasted as it's in the same layer 2 network. But whereas here the ARP is not broadcasted. That's a difference. So the host A will try to ping to host B. That's the first thing. And the ARP is not broadcasted. Okay, so but now the question is, okay, ARP is not broadcasted, but then how the A will come to know the information about the B in order to communicate with each other. So now in this case, the next thing, the switch 1 is going to take that ARP request and it's going to encapsulate that inside the VLAN header, which means now this ARP request, which will be encapsulated inside the VXLAN header. And this VXLAN header will include that particular VLAN or the VNI information inside that. Okay, so that's the next thing. And once it is done, now the question is now the next thing is the VNI. VNI stands for virtual network identifier. That is more similar to the VLANs or the trunk concept. So which means because now this particular user or the device is not present in the VLAN. So now the first thing is it has to identify to reach this particular host, what is the actual switch ID it has to go for. Because the switch 1 should know how to reach the switch 3, means it has to locate which switch identifier it has to send, that is based on the LISP information. It has to reach the switch 3 before it actually reaches the the actual end host. So then it will identify which particular VNI or the VLAN it actually belongs to. So it's going to check that, because in that header, it's going to include that information. And then this particular packet is again encapsulated based on the IP. Now what it will do is, the next step is it's going to encapsulate over an IP packet. So now the ARP request, whatever is being sent, is been encapsulated inside the VXLAN, that is within the VLAN header, and is further encapsulated over the IP packet here. So we can say like this is the outer IP packet, which basically contains the source and the destination of the switch 1, which means in my case, I'm sending it from the switch 1 and switch 3. This will contain the information about the switch, the source and the destination switch, not actual host and destination. Because as I said, in order to reach from A to B, they must know that they should first route the packet from switch 1 to switch 3. Now, the next thing is now in this case, what can happen here is, now there is a possibility that the switch 1 might not have information about the switch 3. Right? So because basically the switch 3 is, because initially the switch 1 may not have the destination IP address of the switch 3 initially. So that can be the possibility. So which means now the switch 1 has to learn about the information about the switch 3, and that's where the LISP comes into picture. Again, we have the locator ID separation protocol, which we have discussed in the control plane section. So the job of the switch 1 is to learn about the information about the the destination switch, that is switch 3, which is implemented with the help of LISP protocol. And this LISP protocol is going to guide the VXLAN packet that in order to reach the destination switch 3, you have to send the packet. Where exactly you have to send the packet, it's going to indicate that. So how to reach? It's going to indicate that particular device. So now, which means now the switch 1 has to send out a query. Basically, now the switch 1 has to query the control plane, that is your LISP protocol, LISP database, about what is the routing locator address of the switch 3. And there will be an addresses, right? So there will be some router IDs. So in order to reach the switch 3, I need to find out what will be the routing locator address or ORLOC address or the location of the switch 3. So the switch 1 has to identify the location of the switch 3. That's where your LISP protocol comes into picture. Again, that control plane node or the LISP protocol is going to replies with this address, and also it will reply with the MAC address of the host P. So which means now when the reply is coming, the reply comes that the switch 3 is located somewhere with 3.3.3.3, and that is your RLOC address where you have to go. And also it also replies with the MAC address of the B, because if you remember, in a traditional method, ARP protocol, as the communication process is going within the same layer 2 network, it has to broadcast and get the MAC address. But in this case, as you can see, the ARP message is not broadcasted. It just wait for the remaining process, and the actual MAC address is learned once it learns the information about the switch 3. So now the switch 3 is going to reply back with the MAC address of the control plane information also replies with the MAC address of that, which means it has the ORLOC address as well as the identifier address, the actual MAC address available. Now, once it learns this information, now what it will do, it is going to fill that information inside the addresses. So now the switch 1 is going to write down that the MAC address of this is MAC A, and this is the MAC B. So it has the MAC address information. It's going to fill inside the VXLAN packet here, inside the VLISP packet, and it is going to send this out to the destination. What is my destination? That is switch 3, because it knows what is the destination address, and forward it out of the layer 3 interface. Like in my case, maybe this forwarding to the switch 2, and then switch 2 will be forwarding out of to switch 3. Now, again, during this process, there is a possibility that there might be multiple connections. So now there is a possibility that, maybe from switch 1 to switch 3, there might be multiple paths to reach out. Maybe there is one more switch here, let's say switch 4. So you might be going from like this. So in case if there is a multiple paths, it's going to use the equal cost multipath. So which means automatically it is going to utilize all the ports or all the paths to forward the packet. So there's no more STP, and there is no more blocking ports, and there is no more primary forwarding ports, or there is no more like that. So by default, it does equal cost multipath, which means if you have 2 routes, it's going to automatically utilize both the routes to forward the packet. So which means now the switch 3 will receive the packet, right? So now we are at the switch 3. Now the switch 3 receives the packet. Now once the switch 3 receives the packet, it has to decapsulate, because if you remember, as I said, the entire packets will be encapsulated end to end with the help of encapsulation, that is VXLAN encapsulation, which contains all this. So now it will start removing this information. So because this is what encapsulation, entire thing, we can say like encapsulation. Now the switch 3 is going to start removing the encapsulation packets, which means now it will retrieve the ARP. Now if you see inside the ARP, it has already the source MAC address of A based on the inner packet, and then switch 3 is going to reply to that ARP request, which means it's going to encapsulate the ARP reply on the layer 3 links and forward it to the host here. So switch 3 is going to simply find out the MAC address and then forward it back to the switch A. So this is how the entire process goes inside the VXLAN data plane. Now, as you can see here, there might be, now this is the device. This is the place where you will be doing the encapsulation. Like if you say, now this device, these are the 2 devices which are called as virtual, probably the VTF devices. tunnel endpoints. But again, the transmit devices might be running a layer 3 network, maybe connecting through routers or maybe connecting through some switches as well, which runs VXLAN. So it depends totally. But at the end, if you are looking out for any kind of upgradations, like let's say you don't need to upgrade the entire network, so probably you just need to upgrade the endpoint. So the VXLAN solution, when you start thinking about the VXLAN providing a solution, that requires the software upgrades only on the devices which are capable of encapsulating and decapsulating the VXLAN packets, typically the edge or the access devices. So which means in the transit, you might be having some routers, let's say. You don't need to upgrade all these routers. So typically they will run a traditional layer 3 or the layer 2 networks. So you can still run on the top again, but the edge devices, which does the encapsulation, requires the upgradation. So this is a complete overview of the steps. Like I said, I think this is what I have summarized, the same thing here. Let me just quickly summarize. Like I said, the host A is going to send out an ARP request, and that ARP request is not broadcasted. So the next thing is the switch one. In my case, the switch one is going to encapsulate the packet inside the VXLAN. And then probably it's going to add the VNI information, which VLAN it belongs to. And again, it's going to add some additional IP header, the additional outer IP header, we can say. And this IP header is basically the IP address of the switch 1 and the switch 3, because the packet is supposed to reach out from between switch 1 to switch 3, right? Now, once it reaches the switch 3, maybe the switch 1 do not know any information about switch 3, if it might be unknown. Now, in that case, it requires the LISP protocol, to identify what is the R-block address to reach out the switch 3. Now, once it learns the information about the switch 3, it's going to fill that information inside the switch 3, and then it's going to do multipath forwarding. And then the switch 3 is going to decapture the packet and reply back to the switch 1. Basically, it's going to, because it knows inside the ARP protocol, it knows the actual MAC address and from where exactly it's coming, the switch 1. So it's going to reply back. So this is a kind of an entire process, what happens in the backend. And if you compare this with the traditional layer 2 networks, it's totally different. So at the end, we'll be using the VXLAN technologies in different scenarios. So wherever we are using, whether in the SDN networks or whether in the data centers, probably this is how, or inside the service provider networks also, this is something what is used. So the backend, this is how it works.